soil, bearing capacity of soils. So here there are different cases are available. The first case is the case 1. So the water table is acting at ground level, ground surface. The water table is acting at ground surface level. Suppose if we can take a strip footing, suppose this is a footing. This is a column load. This is a column, and this is a load coming onto the column. Suppose here this is a ground surface, and the footing is located below the ground surface. So this is a depth of footing, and this is a width of the footing, and the footing around the place is filled with soil. That is, it depends on the soil category. So whether it is cohesive or non-cohesive soils. So suppose if it is cohesive, the cohesive soils is silt and clay soils. And suppose if it is non-cohesive soils, that is cohesionless, non-cohesion soils like gravel, sand. These are the better example to categorize cohesive and non-cohesive soil. So here, how to calculate the bearing capacity of soil. So regarding the ground surface case, the water table is acting at ground surface. So this is the ground surface, the water table acting at ground surface. This is the groundwater table. So, so here in this case, we will take a strip footing. So then the strip footing formula is ultimate bearing capacity equal to CNC plus gamma D and Q plus half gamma B and gamma. So here these are NC and N gamma and Q and N gamma. These are the bearing capacity factor. Bearing capacity factor. Suppose as per Tejagi analysis, as per the Tejagi analysis, if the phi equal to 0 degrees, then NC, that is cohesion factor, bearing capacity factor with respect to cohesion, that is 5.7, and NQ is 1, and N gamma equal to 0. So these are the fundamentals in cohesive soils. So please remember it. So this data is not given any problem. So sometimes there may be chance of given this data in the question. Suppose, so how to solve the ultimate bearing capacity, or how to calculate the bearing capacity of the soil? Suppose if the surrounding soil is either clay soil or non-cohesive soils or both C5 soil. Suppose if it is C5 soil, both the C and angle of friction is affected. So suppose C and C, this is a soil parameter. So C and C plus, so here the water table is affected at groundwater table at ground surface. At ground surface, so here you can observe both depth factor and width of the footing is affected by the water table. So that if it is water table affected by depth with respect to depth and with respect to width, then you can write this case simply instead of gamma T NQ prime plus, sorry, NQ and half, and width is also affected by the water table. This is gamma prime B N gamma. So this is the equation to solve ultimate bearing capacity in C5 soils. So this is the C5 soils. Suppose if it is only cohesion factor, if it is only cohesion factor, so cohesion factor, angular friction is angular friction is 0. If it is if the soil having non-cohesive, that is cohesionless soil, non-cohesive soil, ultimate bearing capacity equal to the same formula you can write here, C NC plus gamma D NQ plus half gamma B and gamma. So here C is the cohesion factor. So here non-cohesive soil, like non-cohesive means cohesionless soil. In case of cohesionless soil, C equal to 0. Then this term is cancelled. The remaining is gamma D and Q plus half gamma B and gamma. Okay. So suppose if this case is the same case as applicable to non-cohesive soils. Suppose instead of gamma, just you can write gamma prime, and this is gamma prime instead of gamma, because both depth factor and width of the footing and width of the footing, both factors, both width of the footing and depth of the footing is affected by groundwater table, so that it is a we can use it as a submerged unit weight. That is, instead of gamma, here gamma equal to gamma prime. So that's it. Thank you.